This video will address ionic bonding, specifically binary compounds. We'll look at both single and multivalent cations. We'll make use of the ionic bonding manipulative that you can download at this link. We'll make use of the chalkboard.com periodic table throughout the video. The upper right-hand corner of each element, you'll find a ionic charge. In the case of oxygen, it's 2 negative, or some might refer to it as -2. Using the manipulative, we see that the anions, or the negative ions, have an indent to represent the number of negative charges. In the case of the positives, they have a projection, also equal to the number of charge. Let's start with binary compounds with single valence metals. Lithium has a charge of +1, bromine a charge of -1, or that is to say, these are the common ions that they will form. Bringing those together, we have complementary charges, a +1 and a -1. So the bonding of this would result in a 1-to-1 ratio. This would give us the chemical formula LiBr. We would call this lithium bromide. But if we were to use sulfur, which has a charge of -2, or forms an ion that is -2, it wouldn't be a 1-to-1 ratio anymore. We'd need to have additional +1, or additional charge on the positive side. In this case, using lithium, we see that becomes a 2-to-1 ratio. That said, the formula that would result would be Li2S, the 2 coming from the fact that there were 2 lithium atoms involved in the donation of electrons. We'd call this lithium sulfide. But when we get into multivalent metals, it becomes a bit more tricky. It's not just about ratios, it's about accounting for which version of the cation we're talking about. So let's use lead as an example. Lead comes in a +2 or a +4 ion. Those are commonly formed ions. If we were to combine this with iodine, we'd have 2 possible outcomes. If we were to use lead 2, we'd find that the +2 required 2 of the iodides to complement the charge. This would give us a 1-to-2 ratio and would result in a chemical formula Pbi2, again the 2 coming from the fact that there's 2 iodine atoms receiving the electrons. But this is where it becomes a bit more tricky, is in the naming. This would be called lead 2 iodide, the 2 coming from the charge of the lead ion. Compare that with lead 4. Lead 4 would require that we have 4 iodides associated with it. So 4 iodine atoms would have to receive electrons from that lead atom. In this case, it's a 1-to-4 ratio, which gives us a completely different chemical formula, Pbi4. The 4 again from the iodides. And this time we would have to call this lead 4 iodide, so that we're able to distinguish it between the other lead iodide, that being lead 2 iodide. Here they are side by side. Let's do one more example. Let's look at nickel, which comes as a 2+ or a 3+. If we use the nickel 2+, if we were to combine that with the sulfur, we would end up with a 1-to-1 ratio, which would give us the chemical formula NiS. This would be called nickel 2 sulfide. Again, the 2 in the name has to do with the charge of that nickel atom. Nickel 3 combined with the sulfur would give us a completely different ratio. We'd end up seeing that it was a 2-to-3 ratio of nickel to sulfur, and would have the chemical formula Ni2S3. We'd call this nickel 3 sulfide, again because the charge on that nickel atom, or nickel ion, was in fact 3. Feel free to subscribe to the channel to see additional videos to help you with nomenclature of chemical compounds.